We'll start with the direct comparison test on the first day, and on day number 2, we'll learn about what's called the limit comparison test. All right, so direct comparison test. What this is you're going to have some sort of a tricky series that's not obvious. It won't be anything that we've done in the past. A lot of times you can compare it against a series that you know about. And usually the series that you pick to compare is either geometric or p-series. And the premise behind this is similar to almost like a transitive property. We do this in sports all the time. Let me just use an example. Let's say that B stands for Beechwood. And let's say that A stands for, let's see, a school we play that starts with A. How about, I don't know, Ashtabula Lakeside? Kind of a new conference member. Let's say we beat them in all sports. All right, both schools are above 0. It's not like we're completely terrible, but let's say that we're greater than them. All right, here's what happens. We're going to say that converging is like losing a game, and diverging, since that goes crazy, we'll say that's like scoring 100 points and routing your opponent. Okay, so first off, if Beechwood converges, let's say that we end up losing to some team. Well, then you figure that Ashtabula Lakeside's also going to converge, since we are better than they are. Conversely, let's say that they diverge. Let's say they beat somebody. We look in the newspaper, we're going to play them next week, and suddenly they beat a team from Pennsylvania. They just crush them. We figure, wow, if we play that team, we would crush them as well because we are, better than Ashtabula is. All right, so just as an example. So this is kind of how we use what's called direct comparison. Some examples will make it kind of hit home for us. So we're going to go to example 1 right now. All right, I'm going to call this summand A sub n, which we usually do. And when I look at it, I think to myself, what is this thing? Is it geometric? No. Can I use nth term test on it? No, it's heading towards 0. A sub n is heading towards 0. It's not geometric, not a p-series. It won't factor, so I can't make partial fractions and use telescoping. All right, since I don't know what A sub n does, I'm going to make up my own B sub n. I'm going to make it something that I know something about. 1 over n cubed. I know that if I throw a sigma in front of this, it's a p-series. In fact, it's a converging p-series because p is 3, that's greater than 1. And you want to state that. You want to write, hey, this is a converging p-series. And because the A sub n has the extra plus 7 in the denominator, everything else being equal, it's going to be less than the blue. Okay, so the inequality sign is going to face that direction. Well, if A sub n, in green, the thing we're trying to figure out, is less than something that I know already converges, then heck, this thing has to converge as well. And we should say it converges by the direct comparison test. Remember, by the time you take your test, you're going to know 10 different tests for convergence and divergence. So you want to make sure that you tell me which one it is. So say that it converges, tell what test you used, just in case I can't tell. All right, number 2. Again, this doesn't look like anything that we've done already. It's not geometric. Telescoping is not going to work. Clearly, we have to do something different. So again, we consider this to be A sub n. Let's make up a B sub n that we can compare it with. And I would vote for 1 over rad n, or 1 over n to the half, which is what that is. Really, the A sub n and B sub n are just the summand inside the summation, so I'm not going to write the sigma again this time. Which one is larger? Well, in this case, the green is larger than the blue because the minus 2 in the denominator kind of helps it. It helps the fraction get larger. Think of a quiz, for example. Let's say that you got, like a 14 out of 20 on some quiz. And then your teacher's like, oh, wait, -2 in the denominator. It's really a 14 out of 18. Well, that's good news. Your grade went up. That's better than if the -2 hadn't been there. Okay, so again, the green is larger than the blue. Oop, I forgot to mention what the blue was. It's my whole game plan. I know that this 1 over rad n, or 1 over n to the half, is a diverging p-series from section 9.3, because p is 1/2, that's less than 1, so this is going to diverge. If you, a sub n, are greater than something that we know diverges, well, you must be diverging as well. Number 3, again, doesn't look like anything that we can identify easily. And although a sub n doesn't look familiar, it does look a lot like 5 to the n over 2 to the n, which could be written as 5/2 to the n. So I'm going to use that as my b sub n. And 5/2 to the n is geometric. It's a diverging geometric series, because our common ratio is greater than 1. Without this -1 in the denominator over here in green, these would be equal. But because the -1 is present, that makes the green fraction larger than the blue. It means that the summation of the green is going to be greater than the blue. Well, the blue diverges. If you're greater than something that diverges, well, then you're going to diverge as well by direct comparison. That's all there is to it. Before we move on to number 4, which will be our last example for day number 1, please write out direct comparison test. Don't call it DCT. We're going to have so many abbreviations going. I won't know what DCT means. And tomorrow we'll have the limit comparison test. Don't write, LCT. Nobody will recognize that. There are some things you can abbreviate. MVT and IVT, of course, from chapter 2. There's a few other things, but not this. Write it out. And also, you want to make sure to write out the fact that what you're comparing it with, you have to say if it's converging or diverging, and you have to say what it is. Again, usually it's going to be geometric or p-series. I suppose you can compare with other things, but usually it'll be one of those two. Okay, on to number 4, final question for today. I look at this final summation and I say, what the heck is that? Nothing I've ever seen before. But I could compare it with this. Now, some people will think that's a p-series, but it's not. A p-series would have an n to the 4th in the denominator, not a 4 to the n. This is actually geometric. You can think of this 1 having an n on it as well. 1 to the n over 4 to the n is really 1/4 to the n. And that is a converging geometric series, which we need to write. Both green and blue would be equal, except the green, the a sub n, has a +3 in the denominator, making it smaller than the blue. So if the green is smaller than the blue, and we know that the blue converges, well, heck, the green must converge by the direct comparison test. All right, that's it for the first part, direct comparison. Now we're up to 6 tests out of 10. All right, limit comparison test will be next lesson. I will see you there. Until then, have a fantastic day.